Dear student, in this lecture we are going to discuss about a capacitor. A capacitor is an electronic device which is used to store electrical energy. Dear student, electrical energy is produced due to flow of electric charges. So basically we can define a capacitor. Capacitor is a device which is used to store electric charges. So we can write the definition of capacitor. Capacitor is an electronic device which is used to store electric charges. Dear student, please keep in mind that capacitors are also known as condensers. They are also known as condensers. There are different types of capacitors available in market. The types of capacitors are based on the shape of a conductor used in a capacitor. So there are different types of capacitor. Some of the known types of capacitors are parallel plate capacitors, spherical capacitors, circular capacitors, cylindrical capacitors, and so on. Dear student, please keep in mind that the name of the capacitors such as parallel plate capacitor, spherical capacitor, circular capacitor, cylindrical capacitor, basically these names are based on the shape of the plates which are used in a capacitor. So in a parallel plate capacitor, usually there are the plates of capacitor which are placed parallel to each other. Whereas in spherical plate capacitor, the plates used in the capacitors are in spherical shape. And similarly in circular and cylindrical capacitors, circular and cylindrical shaped plates are used. This student, please keep in mind that the capacitors are usually consist of plates. These are two plates, and in case of a parallel plate capacitor, these plates will be placed parallel to each other, whereas in spherical capacitors, these plates will be of spherical shapes, and they are basically have a concentric center. So for simplicity, here we are going to discuss about a parallel plate capacitor. Parallel plate capacitor consists of a plate, the and we suppose that this is plate S1 and this is plate S2. So in parallel plate capacitor, both the plate S1 and S2 are placed parallel to each other. And this one, please keep in mind that these plate S1 and S2 in parallel plate capacitors are conductors. There is a medium between the parallel plate capacitors, and the medium between these parallel plate could be either air, it could be a vacuum, or it could be a dielectric. So the student, between the plates of capacitors, suppose this is S1 plate, S1 plate, which is conductor, and this is S2 plate. Between the two plates of a capacitor, there is a region, or there is a presence of a medium between them. And this medium may be composed of an air. It could be either vacuum, or it may be consist of a material known as dielectric material. Now the student, question here is that what is dielectric? Keep in mind that there are different types of materials such as conductors. They allow the flow of current. They allow the flow of current because of free electrons which resides on the surface of the conductors, whereas the other types of materials are insulators. Insulators are the material which do not allow the flow of current. Because their electrons are bounded and they are not free. And there is another type of material which is basically known as dielectric. Dielectrics are the materials which do not allow flow of current. But these materials develop electric field in them. So if we have a dielectric material, suppose that this is a dielectric material, and whenever a potential difference is applied on the dielectric material, suppose if they are connected with a battery, whenever there is a potential difference applied between the dielectric material, plus and negative, these dielectric material will not allow the flow of current. However, the dielectric material basically, so these dielectric material basically get polarized when a potential is applied on them. So there will be a generation of inbuilt electric field due to production of positive and negative charge or dipoles in the dielectric materials. So in capacitors, or in parallel plate capacitor, there are uh, two types of conductor plates which are placed parallel to each other, and between the conductor plates there is a medium. Usually the parallel plates of the parallel plate capacitor could have a vacuum between them, and there may be an air between them, but most commonly the dielectric medium is basically placed between the plates of the capacitors, and this dielectric medium do not allow the flow of the current, but dielectric medium between the plates get polarized when the potential difference is created between the parallel plates in a capacitor, or when a potential difference is created between the plates of the capacitors. So now the interesting question here to notice is that how the electric charges could be stored in S1 and S2 of the plates of the parallel plate capacitors. So now let us discuss that how a charges can be stored in a parallel plate capacitor. Dear student, as since you know that the parallel plate capacitor consists of two parallel plates, and these parallel plates are basically conductors. Suppose this is parallel plate 1 and we give it name as parallel plate S1, and there is another plate and we give it name as S2. So in parallel plate capacitors, both the S1 plate and S2 plates are placed parallel to each other. They are parallel. We can represent them with a symbol of parallel as this. So both the plates are parallel, and both the plates are basically they are conductors. Okay. So now in order to complete parallel plate capacitors, they are basically connected with a potential difference or with a terminal of a battery or with a power source. These metallic uh, uh, plates of parallel plate capacitors are connected uh, with the terminal positive and negative terminal of the battery or with the power source. Suppose that here we connect the parallel plates of parallel capacitor with a DC source with the positive and negative terminal of the DC source. Now, whenever these parallel plates of the parallel plate capacitors are connected with positive and negative terminal of the battery, the positive and negative terminal of battery basically create a potential difference. And due to potential difference, since you know that the positive terminal of the battery basically pull electrons toward itself, so electron will start to flow toward the positive terminal of the battery from S one conducting plate of the parallel plate capacitor like this. So now whenever electron flows toward the positive terminal of the battery, there will be a generation of positive charge on the surface of a parallel plate capacitor on the surface of S1 plate of the parallel plate capacitor. Similarly, due to negative terminal of the battery, basically they push the electrons. So electron will be pushed from the negative terminal of the battery toward the S2 plate of the capacitor. So electron will be basically stored on the surface of S2 plate like this. Now, whenever electrons and positive charge, whenever they are stored on the surface, there will be a creation of a potential difference between the plates, between S1 and S2 plates. So now, if this process continues, there will be a continuous storage of positive and negative charges on the surface of parallel plate capacitors. Similarly, here on this side, a there will be a storage of positive and negative charges on the surface of the parallel plates. So now the more is the amount of charge stored on the surface of the parallel plate. There will be a more potential difference created between the S1 and S2 plate of the parallel plates. Or we can say that since the electrons move from S1 plate toward the positive terminal plate, so the amount of electron are basically shortened on S1 plate. So we can write that there is a shortage of electrons 8 at 8 S1 plates, and whereas on S2 plates the electrons are negatively charged or stored, so this S2 plate will have of electrons excess of electrons. So due to difference in excess of electrons and shortage of electrons, that will basically cause a generation of potential difference V. So if the dear students, so if there is a more shortage of electron on one plate and greater excess of electron is on other plates, this means that there will be a generation of a huge amount of a potential difference. Or if the positive charge are basically produced in a large amount on S1 plate, and negative charge or electrons are present at the surface of S2 plates, so the difference or increase in amount of positive charge and negative on charge on the surface of plate, basically they will cause an increase in a potential difference, which means that a potential difference V is directly proportional to the amount of charge stored in parallel plate capacitors, or amount of charge stored in a plates of the capacitors. So we can say that V is a potential difference between two parallel plate, and whereas Q is amount of Q stored in parallel plate capacitor, or stored on the surface of the parallel plates of capacitors. So now we can write it mathematically as Q is directly proportional to V. And in order to finish a proportionality symbol, we need to write as Q is equal to constant into V. The constant for a plate, for a capacitor, is known as C, which is known as a capacitance of capacitor. So equation will become Q is equal to C into V. So this is equation for a capacitor, for a parallel plate capacitor, and where the C, which is constant, is known as a capacitance of a capacitor, and capacitance of capacitor is defined as the ability of a capacitor to store electric charges. So with the capacitance, if we see the equation of 1, then we can easily draw a formula for capacitance of capacitor, which is basically C is equal to Q over V. Q is the amount of charge stored by plates of capacitor, and V is the potential difference created between the two plates of parallel plate capacitors. So the unit of charge is, that it is a coulomb, and whereas unit of potential difference is volt, so the unit of capacitance of capacitor is coulomb per volt, which is also known as farad. This will now keep very important point in your mind, that since you know that capacitance of a capacitor is a ratio of charge stored divided by a potential difference created between plates of the capacitors. Now But interesting point here to note is that capacitance of capacitor do not depends on it don't depends on the charges, on the amount of charges stored in it, store, and it also do not depend don't depends on the voltage or potential difference created. So now the question here is that why C or the capacitance of capacitor do not depend on the amount of charge stored in it and as well as the voltage. Since you know that the resistance, just like capacitance of capacitor, there are other physical terms like a resistance R and inductor L. All both these resistance and inductors are basically they are the properties of material. Similarly, capacitance C is a property of a material, or it is a property of plates which are used in a parallel plate capacitor, or which are used in any type of capacitor. So this will depend on the dimensions of the plates, and as well as dimension of plates such as length, area, diameters, etc., and as well as the nature of material which is used as a plate in a parallel plate capacitor. So this is all about a capacitor. Capacitor is a device which is used to store an electric charge in, and these electric charge cause or these electric charge form an electrical energy. So in a simple word, a capacitor store electrical energy. The capacitor is basically, there are different types of capacitors. The types of the capacitors depend on the shape of the capacitors. Like the capacitor could be a spherical shape, so we will say it as a spherical capacitors. Similarly, the capacitors are cylindrical and as well as circular shapes. And however, one of the common capacitors used is a parallel plate capacitor, in which conducting plates of the capacitors are placed parallel to each other, and there could be a dielectric medium between the plate of the capacitors, or there may be a presence of air or vacuum between the plates of the capacitors. So this is all about the basic introduction of the capacitors. So in next lecture I will briefly explain about the types of capacitors, like spherical plate capacitors, parallel plate capacitors, and circular capacitors. So thank you dear students for watching this lecture.